right, so in our first lesson, as you can see by my title, we are going to be discussing what we would consider to be some fundamental, foundational concepts, the fundamental building blocks of our study of geometry. And the three concepts that will be the focus of today's lesson will be points, lines, and planes. And jumping down to the bottom of our screen here in this quote, in geometry, points, lines, and planes are considered undefined terms. So that may seem a little bit strange. These are terms that we really don't have a concrete definition of them. We can't just nail them down with a concrete defined statement, because they are explained only using examples and descriptions. So what we end up doing is we will describe these. We will say that they are like something. We have some real life situations that we can use to describe these three concepts, these entities. But there is no true formal definition of them. So let's get into how would we describe, first of all, a point. Well, a point is a location. It has neither size nor shape. We can't put a size or shape on a point. It just references a spot, a location. It is named, the way we name a point, like you can see an example here on my coordinate plane, this blue dot identifies a location. When we name a point, we use a capital letter. So if I wanted to, it really doesn't matter what letter I use. I could say that this, for example, on my coordinate plane, this blue dot is point A. So again, when I'm literally naming a point, then I just use the point and then whatever letter I use to reference that location. Maybe it's called point P, but I use a capital letter to reference that location. Then we jump to a line. If you'll notice, we're progressing. So it takes points to make up our next entity, which is a line. So a line is made up of points. It has no thickness or width. Now I know when we draw a line, sometimes we make it wider or skinnier, but that's just the representation of the line. Theoretically, technically, it does not have thickness or width. There is my next statement, there is exactly one line through any 2 points. And the way we name lines when we describe them and we actually give them a name, we have letters that represent the 2 points on the line, or we could use a lowercase script letter. So I'll just use my coordinate plane here as an example. Let's just suppose I put another point on this line and we call it point B. Then I could say several different things. I could say line AB. I could also use the symbol for line, and that would be an arrow that goes both directions, bidirectional arrow over the letters AB. Or I could also, maybe I want to call this line Q. So that's where we're talking about a lowercase script letter. We could also refer to it as line Q. So there's several different ways that we can identify lines. You could also, it really doesn't matter about the order. If we wanted to call this line BA, that would be fine as well. So any 2 points that fall on the line. we can use in its name. And then notice the progression. We started with a point. It takes 2 points at least to make up a line. And then it takes lines or points more than 1 point. We can have a plane. A plane is a flat surface, all right, made up of points that extends indefinitely in all directions. There is exactly one plane through any 3 points, not on the same line. Okay, we would use the word, we'll talk about this more in just a minute, this would be called non-collinear. So 3 points, if you want to have a plane, it takes 3 non-collinear points. And there's an example of that here at the bottom of my screen. Notice I've got the points E, F, and G. They are not on the same line, so that constitutes a plane. And the way we name a plane, there's several different ways. We can use a capital, notice different than a line. A line uses a lowercase script letter. A plane uses a capital letter. So in this case, using my example, I would say plane P, if I wanted just to use the capital P. Notice this isn't a point, it's the actual name, capital letter name of this point, of this plane. We also could say, using the letters of the points, we could, and it really doesn't matter about the order, I could say that this is plane GEF. And I won't list out all the possibilities, but you could also say plane FEG, EGF, all the different arrangements of those points. It really doesn't matter. They all can be used. And so those are the 2 ways of giving a plane a name. All right. So other concepts, we've touched on this a little bit. You're going to see these terms come up from time to time in your study of geometry. What are collinear points? These are points that lie on the same line. Pretty basic. And the alternative or the converse, the counter example, I guess you could say, is we could have non-collinear points. These are points that do not fall on the same line. So this is like the antonym, I guess you could say. And then you can have coplanar points. These are points that lie on the same plane. And then again, the antonym or the converse of coplanar would be non-coplanar. Okay, now in your notes, just to kind of give you a heads up on how the course will work, I will typically in the first part of your notes give you some key terms, concepts, ideas that are important in your being able to do the homework assignment. And then after that, after we've established some groundwork and given you some important information, then I'll give you some examples of problems that are similar to what you will do in your homework assignment. All right, so let's just take a look here. We have this figure. It's a plane. There are 2 lines that actually intersect. They cross each other. Just to kind of give you an idea, we have this line called N. It's also described by any of the 2 points that are on the line. And that line is on the plane. And then we have this line that is straight up and down that actually isn't on the plane. It's going vertically. So you see these dots. The dots represent the part of the line that you really can't see. So you got to kind of visualize, get this in your mind, what this line T is doing. If just picture vertically going straight up and down, not lying on the plane. Okay, so let's see if we can take this figure and answer some questions. So a line containing point W. All right, so obviously here's point W. So point W falls on line N. So we've got several different correct answers here. We could say line N using the lowercase letter. We could say any of the points. We could say line VW. You could also do VW using the line symbol above the letters. Oh, sorry, VY. I said VW. And you could actually do that with any 2 points that fall on this line. So there's more than one correct answer. I just listed a few. I won't go through and list every single one, but hopefully you get the idea. So letter B says, what is a plane that contains point X? Well, point X is right here, and it falls on plane P. You could also use any 3 non-collinear points to describe the plane. So here's another acceptable answer. W, Z, Y. Those are 3 points that are on the plane that are not on the same line. So I won't go through the whole list, but those are 2 possibilities of naming that particular plane. All right, a plane that contains points T and Z. Remember the definition of a plane. It's any 3 non-collinear points, and we can make, there's several different options here as long as we contain the points T and Z. So I'll change color here. So here's T, of course, here's Z. So those 2, along with any 3rd point, would make up a plane. So we could say plane, even though it's not this given plane called P, it would be a different plane because T isn't on that plane P, but we can make up any plane. A plane is made up with 3 non-collinear points, so we could say T, Z, and X. Or if you wanted to, T, Z, and W, those are non-collinear. Any 3 non-collinear points. And then finally, letter D, a line containing point T. All right, so we could say that that's line R using the lowercase script letter R down here at the bottom. We could say line TX or XT, or we could also use the symbol using the letters TX. Any of those would be fine. There's, again, based on what we talked about on our previous slide, there's several different ways of naming a line correctly. All right, let's talk about some real-life examples. Name the geometric term. All right, and so we're dealing with lines, points, lines, and planes. And in some cases, we may get into intersecting lines or intersecting planes. Let's just talk about this, for example, stripes on a sweater. Well, stripes on a sweater would represent lines. Or we'll just go singular. Point, line, or plane, or maybe we have intersecting planes. The corner of a box, that would represent a point. A point is always formed where 2 lines intersect. And we could also say that these are intersecting lines. A 10 by 12 photo, well, remember what a plane is. It's a flat surface that technically it extends infinitely in all directions. And I know a 10 by 12 photo doesn't actually do that. But again, we're just talking about a representation, a description of what a plane would look like. So letter C would be a plane. Letter D, a button on a table. That would be a point. One side of a roof. So if you think about it, let's just see if I can do a little artwork here. Just one side of a roof. So we would have the other side. So here's the middle of the house. So just looking at one side of a roof, that looks like a plane. A plane is a flat surface that extends infinitely in all directions technically, but again, I know a roof doesn't, but it is a representation of what a plane is. It's made up of points that extend throughout both directions. So we could say it's a plane. And we could also go one step further. If you notice that these are lines that intersect, excuse me. So we could also describe this as intersecting lines. In letter F, we have two connected walls. So two walls that are connected, that's like two different planes that intersect in a line. So we'll call that intersecting. Intersecting planes. Move that toolbar out of the way. Okay, that takes care of those examples. You'll see some of those on your assignment. And let's see what else we got. The last type of problem, you are going to do your own figure. You're going to draw and label a figure that describes each relationship. Okay, so let's take a look at letter A. A figure where line Q intersects plane T at a single point. All right, so I'm going to draw a plane. Okay, now if I just draw this line Q to where it falls directly on plane T, then I'm going to have I'm going to have an infinite number of points that intersect plane T. But to show it where it just intersects at one point, this is where you're going to draw this up and down line, so it'll look like this. So the point that you can't see, that's where you're going to make the dotted line. So using your imagination, you got to kind of think of a different way of looking at these in space. The line intersects plane T right there, excuse me, before the dotted line. So the dotted line represents the hidden part of the line. And so we'll call this line Q intersects plane T, and there's our single point of intersection. All right, letter B, three lines intersect at point M, but do not all lie on the same plane. All right, so let's take a look at this. So here we have a plane. Call it M. So we can put two lines, maybe I'll do a different color. We can put two of these lines on the plane itself. So here are two lines. You can see the entire line on plane M. And then for this third line, as long as all three do not lie on plane M, this third line I'm going to do like we did up here in example A. So I'm going to show this third line crossing that point of intersection, but then it's like it goes straight up and down. All right, so three lines intersect at point M. Sorry, I called the plane M. Should be point M. They didn't give us a name for the plane, so there's point M, and there's three different lines, but not all of the lines. One of the lines does not lie on the plane. It goes straight up and down. It's different than the other two. All right, and then finally, line AB and line EF intersect at this point. So this is the coordinate plane. So we'll go ahead and draw our pair of axes, the X and the Y axis. So you don't have to have graph paper for problems like this. You can just sketch out your own coordinate plane. And let's just go ahead and identify this point R, which is the point of intersection of these two lines. Two, 5. All right, and we know that the line AB, we only know the coordinate of one of the points on the line. We don't know what B is, but as long as we know where A is at 0, 7. So I'll just go up a couple more. And so we'll say this is A, 0, 7, and this is point R that we plotted earlier. And then we'll go ahead and plot point E, which is one of the points that we're told on this line EF. E is at the point 5, 8. And 5, 8 would be up here, just a little bit higher. This is 7. So we'll say that's 8. Again, just a rough sketch. All right, and so now we're going to show lines that intersect at point R. We don't know, we're not given, again, we're not given where point B is, so it really doesn't matter where you put it as long as you make it collinear with A and R. Okay, and you don't have to give me any specific ordered pairs as long as you show that it falls on the same line in your sketch. So I'm going to say that point B is right here. And now I've got this line going through point R. And then this was point E. And so point F needs to be collinear with E and R. Again, doesn't matter where you put it as long as you make them collinear and indicate that with your line. All right, so there's a graph representation of what is being described. These two different lines intersecting at a point called R, and then given these two coordinates, we can reason through where the other should be. Again, as long as they're collinear, then that's no problem. All right, I hope this helps. These are some examples that follow pretty closely with your homework assignment. If you do run into questions or if there's something I can do to help you in this assignment, please let me know.